Okay, welcome to the January 2025 Lunch and Learn. Happy New Year to everyone. And welcome to our first Lunch and Learn. So we do these typically the first Monday of every month. We push it back a little bit, just getting back from the holidays. And actually, we were processing cider last week. So we were busy doing that. What I like to do with these, just as a reminder, I'm going to go through the presentation. It is being recorded, and we'll put it up on our YouTube page for you to go back and look at the presentation later. We'll have a discussion at the end, though. We stop recording before the discussion. That way, if anybody wants to share their experience, you don't have to feel like the entire internet's going to know what you're doing in your winery or what problems you may have had in the past or things like that. So we don't share on the recording the discussion point. Okay, let's jump into it. So today we're going to talk about malolactic fermentation. The reason I wanted to talk about this today was I was hearing from some winemakers that it was something they wanted to try, that they hadn't tried it yet. They've been making wine for a little while, and I just thought that was interesting because I thought it was a more normal thing for everybody to be doing. And I thought, well, let me do a presentation and maybe fill in some of the knowledge gaps there about why we use malolactic fermentation, how we can perform it, benefits, drawbacks, things like that. So let's jump into it. So as a reminder, what is fermentation? A lot of times in winemaking, we say, we consider, we get a little bit lazy and we say fermentation is alcoholic fermentation. The other way we call that in winemaking is primary fermentation. So it's usually the first, or let's just say the most important fermentation we're doing is the conversion of sugar into alcohol. Fermentation in general just means the chemical breakdown of a substance by bacteria, yeast, or other microorganisms. Usually we break fermentations into two groups. There's usually fermented foods, and this is in the academic world. There's fermented foods, and there's lots of benefits, and there's a lot of study going on right now with different fermented foods and health and things like that. But we can use a number of different microorganisms to generate those fermented foods: cheese, soy sauce, bread, beer, wine, sauerkraut, kimchi, all kinds of things. I think tofu, lots of different fermented foods out there. And you're not always making alcohol. That's my point here, is I want you to understand that fermentation doesn't mean you're making alcohol. You're just doing a conversion of some chemical to another chemical with a microorganism. And then the other side, I should say, is industrial fermentation. So using microorganisms to produce pharmaceutical compounds or breaking down different oil-related compounds, things like that. So that's the industrial side of it. So that's kind of the way we break down fermentation in the academic world. So just showing you a quick, here's some of our fermented foods that we can make. By no means is this all of them, obviously. Another thing I wanted to point out, we're going to be talking a lot about bacteria today. And remember that we use yeast to do our primary fermentation. So Saccharomyces cerevisiae is this guy here, the letter A. So it's a big cell. Okay, it's a eukaryote. It's a big cell. And bacteria that we're going to use to do malolactic, they're tiny little cells. Okay, so keep that in mind, especially when we're going to maybe do filtration or get rid of those bacteria cells. They're a lot smaller than yeast. So just wanted to remind you of that. Okay, so we're going to use a type of bacteria called lactic acid bacteria to do malolactic fermentation. Now, some of these bacteria are good, some of them are bad, but they're a group of bacteria. And if you remember any of your biology, gram-positive membrane, I won't get into it, don't worry, I just letting you know. And so all lactic acid bacteria can generate lactic acid from some source. Doesn't have to be malic acid. Sometimes they use glucose to generate lactic acid or other sugars or malic acid. So anything that produces lactic acid is a lactic acid bacteria. So there's a couple different types of these labs, these lactic acid bacteria. The one we're going to talk about mostly today is Enococcus eni. So it's the main bacteria we use for MLF. We like it because it's acid tolerant. It does what we want it to do without, so conversion of malic acid into lactic acid, without creating too many off aromas or off flavors. So it's a pretty clean fermenting type of bacteria. It's fairly acid tolerant. Its growth is inhibited at 10% ethanol. Keep that in mind when we talk about sequential versus co-inoculation. Cockeye spherical type cells to small rod type cells and chains, pairs and chains. Okay, this is Enococcus eni over here in this picture, and they do really start to form long chains as a fermentation goes on. Lactobacillus is another subgroup of lactic acid bacteria. Lots of different lactobacillus species out there. Some species are responsible for wine spoilage, so you can get acetic acid production, geranium taint, mousiness, bitterness, diacetyl. So things that we don't necessarily want. They're usually longer rods, and they're usually in single cells. And these are things that we would see under the microscope if somebody sent us a sample and we were, trying to identify what these were. Pediococcus is another lactic acid bacteria. So coccus means spherical. So there's small and spherical in shape, and usually in pairs or tetrads, so 4 of them. And again, some of them are responsible for spoilage. Most of the pediococcus, though, only exist at the higher pH levels. So at the lower pH, they're usually not surviving. Okay. So let's get into malolactic fermentation. What are we doing? We're taking malic acid, which is this molecule on the left. Don't get too scared yet, okay? Because I'm showing you some chemical structures, but malic acid, we're going to lose a carbon dioxide during the fermentation, which is pretty typical. And we're going to generate lactic acid. So a couple things I want to point out here. Malic acid has a carboxylic acid group on this side and a carboxylic acid group on this side. Okay, so this H here and this H on the other end are both acidic. Flip over to lactic acid, and we only have one carboxylic acid group. Okay, it has to have this double bonded O connected to this OH to be considered a carboxylic acid. Anyway, so this H is acidic. So we've gone from 2 acidic H's to 1. So you drastically reduce the amount of acid in your wine. And this is also a weaker acid, okay? If you tasted it, this tastes a lot less acidic. So green apple is how we describe malic acid. That's what it reminds us of, and it's in green apples and in apples in general. And lactic acid is the acid you taste in milk. So I think hopefully that's fairly obvious to you, the difference in acidity levels. Okay, so let's jump into this a little bit more. And I'm going to throw this is high school, maybe first year level chemistry here. But and I tell this to my students, the students that work in our lab all the time, if you can get a handle on acid-base chemistry and the pKa's, okay, pKa's are a level of acidity that is specific to each individual compound. If you can really understand that, you're going to go a long way in understanding wine chemistry. So this pKa1, let's say for malic acid, is the pH where you have 50% with the H attached, 50% with the H unattached. Okay, and that's the definition of pKa for everything. So so we've got a pKa of 3.40, so it's low, and then a pKa of lactic acid of 3.86. So it raises the pH, or it lowers the acidity. Remember, the higher the pH, the less acidic it is. So why are we doing MLF? Okay, so you get this reduction of acid. That sounds really awesome, right? For our hybrids. We've got lots of acidity in there. So you do get a reduction of acid. Another benefit to this is microbial stability. Lactic acid bacteria tend to be everywhere. Let's just say that. There's lots of different species. They live in nooks and crannies in your winery. And so if you let them do their own malolactic fermentation, if they start chomping up on your malic acid and creating lactic acid, chances are they're going to do some other side reactions that are going to taste not so great. Okay, so you're stabilizing, you're taking away that food source for those spoilage microorganisms. Mainly in the overall wine world, malolactic fermentation is mainly performed in red wines and in whites. And in some whites, so like Chardonnay. And the reason for that, historically and traditionally, is those wines go into barrel. So if you're going to barrel age your wine, first of all, I would say at this point, consumers expect the buttery creaminess that goes along with oak aging. Okay, that's a profile that we expect these days. But it's also, you would perform and inoculate for a malolactic fermentation to prevent the, again, I said that lactic acid bacteria loves to live in nooks and crannies. Barrels are full of nooks and crannies. And you're going to have, if you don't inoculate with malolactic fermentation or malolactic bacteria, and you put your wine into a barrel, there's a very good chance that you will have a spontaneous malolactic fermentation happen. Okay, better to control it, in my opinion, better to control it yourself and put in some bacteria that you know that are going to do the job properly. Okay, so anything that will undergo barrel aging should go through MLF. That's a suggestion. And it's a standard profile for most red wines these days. I will say that the Enococcus eani that I was mentioning before that we inoculate, it really is only tolerant at 3.2, pH of 3.2. So when I said our hybrids could potentially benefit from this, if you're looking at a wine or juice that has a pH of 3.1, 3.0, you're going to have a very, very hard time of getting that malolactic fermentation to start. Those bacteria are going to be extremely stressed out, and it can be very difficult to get those to start. So 3.2, most of our reds, I think, Marquette, Frontenac, Petit Pro come in totally fine for that. If you're looking at doing malolactic on a white, make sure that you're at least at 3.2. I mean, 3.18, maybe you're going to be okay there. But I wouldn't go anywhere below 3.1 because I don't think your bacteria are going to survive. So just keep that in mind. Okay. Factors affecting malolactic fermentation. So this leads us into the different ways to inoculate for malolactic fermentation. So there are things that will inhibit, there are things that will promote MLF bacteria, and a lot of them are the same things that will affect yeast, okay? So nutrient content, pH, temperature, although not as much, they're pretty tolerant to the temperatures we have for wine. Alcohol, sulfur dioxide, and other inhibitory compounds. So just going through this for a second. Alcohol, above 10% alcohol, you're going to have a hard time getting your MLF to kick off. You're going to want to build a fairly good, strong starter. I'll talk about that in a second. SO2, so these bacteria tend to be very sensitive to SO2. So when you're done, you want to kill all your bacteria off because you're done your malolactic fermentation. SO2, should do the job, no problem. pH, I just mentioned that, below 3.2, you're going to have a hard time. Nutrient content, you do want to make sure, especially if you're doing a sequential inoculation, that you've got some nutrient in there for those bacteria to survive. And sequential means after alcoholic fermentation. And then there's some others, but those are the main contributors, is that alcohol, pH, SO2. So how can you perform an MLF? There's two different, probably multiple different ways, but these are the two ways I'm going to talk about today. Sequential inoculation or co-inoculation. So sequential is when you do your alcoholic fermentation first, you wait for that to finish, and then you do your malolactic fermentation. That's the traditional way of doing it. And there are probably still winemakers out there that have been doing that for a really long time, and it's their tried and true method, and that's how they continue to do it. So they only inoculate for malolactic fermentation after primary fermentation is done. And that's a lot of times, if they're going to put their wine barrel down or put their wine into barrel, that they might inoculate for malolactic fermentation at that point, and then let their wines kind of just hang out and perform that malolactic fermentation in the barrel over a couple of months, maybe. Remember, you've got alcohol in there that is going to inhibit those bacteria. And so it can be challenging to get that to kick off. The other option, which has become much more popular in the last, 5 years or so, is co-inoculation. So this is where you add your malolactic fermentation bacteria 24 hours post inoculation with your yeast. So you add you crush your grapes, you add your yeast maybe that day. Okay, if you're making red wine, I inoculate that day. You might do a cold soak or something like that, and that's totally fine. But you add your yeast. 24 hours later, you add in your malolactic bacteria. Okay, so let's talk about the differences and why I think co-inoculation is the way to go. With sequential inoculation, you cannot add SO2 to your wines. So you do, 2 weeks, let's say, of your your alcoholic fermentation. Now you're going to add in malolactic fermentation, which if you put it into barrel, it might take a couple of months. I remember one of the wineries I worked at, we were into January measuring MLF to see if it was finished. So it took that long. You can't add any SO2 until it's done. That's a risk. That's a risk of not protecting your wine. And other microorganisms can grow, other spoilage yeast, other lactic acid bacteria, and they may produce some flavors that you don't want. So that's a risk with sequential inoculation. I also think it's a risk to even get the malolactic fermentation to start, because you've got higher ethanol concentration in your wines, and your nutrient for the bacteria may be depleted because that yeast may have eaten it all up during primary fermentation. So you want to get a good starter going. You want to build up those bacteria, maybe a couple days, maybe add some of that wine into it, into a starter, a bucket or something you have off to the side, and maybe in a warmer spot than the winery, to get those bacteria nice and happy and active before you put that in. So it's a little bit more involved. On the flip side, co-inoculation, 24 hours after yeast inoculation, you dissolve your bacteria at least the inoculum that I use, the product that I use, and you dissolve that up in room temperature water. Then you add it straight to your tank or your bins, my macro bins. I just kind of squirt it a little bit around, however much I need. Punch that down, let her go, let her rip. I will say sometimes, so if alcoholic fermentation comes to an end, sometimes it might take a couple more days, maybe a week longer max for MLF to finish with a co-inoc. There are specific strains out there now that companies sell specifically for co-inoculation. And I've had good success. I've had good success with co-inoculation. I know I've heard a couple other people say that it didn't kick off. And I did want to point out a couple of charts here at the bottom. This is from Lallemande. I'm pretty sure it's Lallemande, who is a yeast and bacteria company. They did some studies. So the one on the left here, what you can look at is these closed red squares. So that is co-inoculation. Okay, so this is the amount of malic acid that they have. They inoculated one day after, and the amount of malic acid decreased quite quickly compared to a sequential inoculation, which is the blue. And you can see here they added in, this arrow says that that's when they added in the bacteria for the sequential inoculation. And they got a good drop in malic acid, but then it carried out a very, very, very long time. So if that's a risk you want to take, the one thing I would say, if you want to do sequential inoculation, taste your wine often. You want to make sure acetic acid doesn't get out of hand, Brettanomyces doesn't get out of hand, other spoilage microorganisms. So taste the wine often to make sure that you are getting, that you are not creating any more problems. Okay, and then, yeah, just another, you will get less other aromas. So if you think that volatile phenols are a good thing, here's the thing. Other microorganisms might bring in a level of complexity to your wine if you do a sequential inoculation that you may be looking for. And a little bit of Brett is okay to a lot of people. A little bit of acetic acid when it's just below the threshold is okay. However, I think the risk of letting those microorganisms go wild or go crazy is not worth it. I would rather have a clean fermentation and not risk complexity by allowing microorganisms to thrive. That's my opinion, but that's where I would say if you're going to do sequential, taste often. Okay, so how do we monitor MLF? We're lucky here in the lab. We've got a couple sophisticated ways of doing it, and it's not very difficult. It can be challenging in a winery setting. Chromatography is usually the way that people do it in a winery setting, and this is what a chromatogram or your chromatography might look like. You would have your standards, and they all come with a kit. You buy a kit from somewhere like Presqu'île or Wine Pro or Vintner's Vault or something like that, somewhere like that. Everything comes with it, the paper, the container, the standards. So you dot your standards here. This is where malic acid's going to come out. Okay, lactic acid, tartaric acid. And then you dot your samples. Okay, so this winemaker has 4 samples they're trying. So if you were to read this, wines 1 and 2 are complete. And the only way you know that they are complete is there is no malic acid present. Okay, so the presence of lactic acid is great. You know, it means that things are happening, but you need to see that there is no malic acid in order to say that it's that the MLF is complete. And that's the same thing we use when we're doing either the enzymatic kit or HPLC. There needs to be 0 malic acid left. I mean, we have a threshold. I think it's 0.3 milligrams per liter, but you're starting at 5 grams per liter of malic acid. Okay, so it's a massive reduction in malic acid. So we use an enzymatic kit, which is quite easy for us to do, quite quick. You do need a spectrophotometer if you're interested in doing this in your own winery. A spectrophotometer can be used for a lot of different analyses. At our lab, it's $35 or $31.50 if you're here in Iowa. Now, on the flip side, we can also run an HPLC, so high performance liquid chromatography, which is actually kind of similar to this, but we won't get into that. Anyway, specialized equipment required. But if you want to run this HPLC for the same price as just doing the malic acid enzymatic kit, you can also get your concentration of tartaric, lactic, citric, and acetic, which is actually, you know, something you should be monitoring anyway, right? Acetic acid for volatile acidity. So consider it. It's a really short, easy experiment for us to do, and it costs the same amount, and you get 5 pieces of information instead of 1 with the enzymatic kit. So just something to consider. Okay, so problems that you may have with MLF. There's 2 main, if you use Enococcus eni as your bacteria, there's 2 main things that could go wrong. The first is geranium taint. If you are making a wine, you do a malolactic fermentation on it, and then you add sorbate to it, because let's say you wanted to sweeten that wine up. And so you use sorbate to act as a yeast inhibitor. Any bacteria that is still present will convert, and I say will because I've seen lots of examples of this, and it's not worth the risk. But any bacteria present is going to convert the sorbate to this compound here called 2-ethoxyhexa-3,5-diene. What geranium leaves. And I don't know about you, my mother loved to plant geraniums. I think they're easy to grow. They stink. They stink so much. And I'm really sensitive to it. And maybe you aren't, but I'm just warning you, I've seen many, many examples of geranium taint here in the Midwest. So don't use sorbate if you are going to do an MLF on that wine. What should you use? Sorry, my internet goes in and out a little bit. Geranium taint, don't use sorbate if you have performed an MLF on a wine. But you might say, Erin, I got to use sorbate. I sweetened the wine. SO2, SO2 at the proper amount based on the pH that you have, and sterile filtration. We have done a lunch and learn about sterile filtration and bubble point testing. Please go and check that out. Okay, if you are doing your sterile filtration appropriately and your SO2 is being used appropriately, you should be fine. Should be no problems. Okay, excuse me. Diacetyl. So Enococcus eni does produce diacetyl. It is a compound that is that's okay. It in small amounts gives you the buttery sensation or buttery aroma. In larger quantities, though, it can smell like rancid butter, and so not very good. Strain selection of malolactic fermentation bacteria can help prevent that. So I know Scott Labs has a strain tells you which ones produce more diacetyl or less. It can be produced during, so it's produced in higher concentrations in slow malolactic fermentations. And where are we going to get slow malolactic fermentation? Sequential inoculation. Okay, so co-inoculation, you should have low concentrations of diacetyl. So just FYI, that's kind of how that works. So one other thing that I wanted to point out with malolactic fermentation is that there is a yeast that was genetically engineered to perform malolactic fermentation. And it was developed in Canada, in British Columbia. It does have generally regarded as safe status here in the US, but I cannot find where it is commercially available. If anybody knows, let me know. But I cannot find MLO1 available here in the US. And I think most of that is has to do with it wasn't accepted very well by winemakers. People didn't want to use a GMO yeast. It would essentially be the first one out there that was used. So I can't find it, but I wanted to tell you a little bit about it because you might read about MLO1 and want to ask me about it. So what they did was they took from Enococcus eni, they took the gene to for the enzyme to convert malic into lactic. So there's one gene or there's one enzyme that does that. So they took that gene, stuck it in here. Now, the other thing that was missing was a transporter. Yeast, Saccharomyces cerevisiae, cannot uptake malic acid. It can't bring it into its cell because of the membrane. And so there is a transporter in this yeast called Schizosaccharomyces pombe. Okay, maybe I've talked about it a little bit with spoilage yeast and whatnot. It's a spoilage yeast, but it's not super, super bad. But it has a transporter. So they took that gene and stuck it into Saccharomyces cerevisiae. So now these genes are here. So this yeast is actually making the transporter and the enzyme itself. Okay. And so it was able to uptake malic acid and convert it into lactic acid. And it works. It works. I'll be honest, I don't know how effective it is at alcoholic fermentation and how effective it is at doing both at the same time, but it does work. The other product you might see out there is called ProMalic, and it is actually one of these Schizosaccharomyces pombe yeast. It's not a Saccharomyces cerevisiae, it's a Schizo yeast, and it's encapsulated. And so it can convert malic acid to ethanol. So again, it can uptake the malic acid and it can convert it into ethanol and spit it back out. So you're not generating lactic acid necessarily, but you are decreasing your acidity. Unfortunately, this is not available in the US. It looks like it's mainly available in Europe. And it's not a GMO because it is a natural yeast that's encapsulated. And the reason they encapsulated it was so that it was easy to remove at the end, because you don't want Schizosaccharomyces just living in your wine. So it's encapsulated, so it essentially floats or settles out really easily, and you just, you're able to get rid of it pretty easily. So I wanted to point that out because if you're doing some more reading about MLF, you may see MLO1 or you may see this ProMalic and wonder if we can use it. And fortunately, I can't figure out where it's available. So to wrap up, malolactic fermentation can be used to lower acidity and protect wine from microbial infections from lactic acid bacteria. Co-inoculation, in my opinion, has less risk factors. Doesn't mean you should do it. You need to evaluate what is best for the style of wine that you're going for, what your comfort level is, what your experience is when you're using barrels and things like that. But it has less risk. It does have less risk factors with co-inoculation. I strongly recommend monitoring malolactic fermentation because as soon as it's finished, you really want to protect your wine with SO2. Using sorbate on a wine that went through malolactic fermentation is a major risk. I have seen, before moving here, I'd never smelled geranium taint. in a wine. It was one of those mythical spoilage faults that I had never smelled. I smell it regularly here in the Midwest because we make a lot of sweeter wines, and people want to use sorbate, and I get why, but be careful if you're doing malolactic fermentation and then using sorbate. There are other ways to reduce acidity. You don't have to just use malolactic fermentation. You can add sugar to balance out that acid. You could add water to bring down the concentration. You can use carbonate but I hesitate on using too much carbonate because you can get chalky flavor. And you can blend. You can blend different wines to try and bring down that pH. Or sorry, I should say raise the pH. So there are a couple other ways. And then in the vineyard, you can let things hang longer. Sunlight exposure, things like that can usually help with decreasing acidity. And so I just want to say you can contact me. Jossie put up a couple of, put up a little link there if you are interested in any of that analysis, and we can walk through that. And upcoming for our Lunch and Learn series in February, Randall Voss is going to be here talking about pruning, so fairly timely. And then March 3rd, Sarah Pirtle, our extension and outreach specialist, I believe she's going to talk about no low alcohol wines and how those are made, and maybe some considerations that we need to start wrapping our heads around as small producers, and whether we can do that as small wine in small wine production. April 7th, to be determined. If you have ideas or a topic you want me to cover, please let me know. And I just want to point out the Iowa Specialty Producers Conference, which I will be speaking at along with Randall and Sarah, is in Ankeny, February 11th and 12th. So please check out the agenda for that and see if there's some interesting things and if you'd like to come to that.